Hello everybody, today we are going to be taking a look at this longer problem, but the problem is going to be a little bit different than what we usually do. Usually we focus on a specific type of problem using graphs, trees, linked lists, or dynamic programming or something like that. Today we are going to be using something known as the greedy algorithm strategy to try to solve this problem. And we'll go more in depth into what that exactly means, but first let's take a look at the problem and what it's asking for. So you are given n activities with their start and finish times. Select the maximum number of activities that can be performed by a single person, assuming that a person can only work on one activity at a time. So essentially we're given an input, a list of tuples, activities, a list of tuples which contains a start and end time, and then we're going to be returning the maximum number of non-overlapping activities. So the problem sounds pretty long, but if we take a look at an example, it might be easier to comprehend. Basically, there's going to be a list of tuples. So here we have a list of 3 different tuples, and each tuple is representing an activity. So for example, this first tuple, it goes to 1 to 4. So it could be like 1 p.m. and 4 p.m. or like 1 hour in and 4 hours in, doesn't really matter. But essentially all we know is that this first activity goes from 1 to 4, this one goes from 5 to 7, and this one goes to 8 to 9. Since you see that 1 to 4 is different than 5 to 7, 4 is before 5, there's going to be this gap period of between 4 and 5, and there's a gap period between 7 and 8. We know that each of these activities are not overlapping, so the output should be 3. However, for example, if this activity went from 3 to 7, then we see that there's obviously some overlap between these two things. So there we would have to say maximum number of non-overlapping activities is going to be 1, because there's only one activity that doesn't overlap with the other two. Alright. Sorry, just a small correction. Essentially, in this example, if this number started with the number 3, there would actually be 2 overlapping activities. The reason being, these first 2 things can be completed with one person can choose to complete either this one or this one. They can't complete both, obviously, but they can complete one of these two as well as this one. So that means their total number of activities that a single person can perform is going to be 2. So in this case, it would be 2. Alright, so what is the greedy algorithm approach that we're going to be using? So a greedy algorithm approach is basically where we start by choosing the best possible outcome. So we start with the most optimal solution. So in the beginning, we assume that we can attend all 3 of these activities, but however, as we progress, we note that there's going to be some conflict. Like, okay, we can see here that, oh, there's some time conflict between here, so then we exclude this element from the list. And then we're just going to be continuing iteratively throughout this list and continuously seeing that which activities can be completed by a single person and which one have to be excluded because of the time conflict. Alright, so the first thing we're going to be doing is we're going to be sorting the activities by their end time. So we're going to be making sure that just like this, like in this period right here, you see how when we're going through the greedy algorithm, we want to focus from the beginning to the end. So what we want to ensure is that all of the end times are going to be the same. Then what we're going to be doing is we're going to be selecting the next activity and then selecting the first activity and only going to the next activity if we know that this value is more than this value. So that's basically a basic explanation of how what our general approach is going to be, and how we are going to be using a greedy algorithm to achieve that. So let's define the function, define activity selection, and then we're going to have activities. Now the first step is we're going to be sorting this list by the end value of the tuple. So the simple way to do this in Python, there are multiple different ways we can do this, but we're going to be using the sort function. We're going to be sorting activities, but the way we're going to be doing this is we want to make sure that we're sorting by the second element. So what we're going to be doing is we're going to be defining a key. Key is equal to lambda of x of 1. So essentially what lambda does is it creates this sort of temporary function basically, where it instead of like having to create a whole another function, we can use the lambda x, and when we're specifying x of 1, we're specifying the index of 1 in the tuple, which is going to be that second value. So we are going to be essentially sorting the list by the value of the second index in the tuple. So there are multiple different ways to do this. If you don't want to use lambda, you can also manually create a function, but probably not going to give the explanation for how that works either. But yeah, essentially this is how you would sort the list like this in Python. Next, we are going to make a list. This is the output list that we are going to be basically we're just going to be creating the list for the number of tuples. So like when we find a tuple that is non-overlapping, we'll just be adding it to the list, and the final value we're going to be returning is the length of this list. We can just have it as an integer as well, but I think for general purposes, we are going to be using a list, storing all the tuples into this list, and then returning out the length of the list. So we're going to start by, like we said, we're going to be sorting based off of the end time, but we need a variable to keep track of it. So we're going to start by having the variable be set to 0. Now we're going to be looping through the activities list. So the activities list that we got, the way we're going to be looping through this in Python, what we can do is say start comma end in activities, and you notice how each list in the list it contains a tuple with 2 elements, essentially start and end. So we're going to be having, when we're saying activities, start and end refers to the first and second value of the tuple in activities. So now what we're gonna say essentially is if start is greater than equal to last end time, because essentially that's what we're looking for. If this value is greater than this value, we can just simply append selected dot append. We're going to be appending the tuple because we can append it to the list and we know that it's a non-overlapping list. And yeah, then we're going to be setting last underscore end time to the end value of the tuple. We're going to be setting the end value, so the end value always starts off at 0, but then it's going to transition to this value. So yeah, hopefully that makes sense. If you want to see the code, well, first at the end of this code, it's pretty given that we can return selected. We can also just return length of selected. I think that's probably the easier way. Since all we need to do is get this value, so we're going to be returning the length of the selected list. Oh shoot. Sorry, I think I cut off before I wrote this. The last end time is going to be set to the end value. So the end value is the second value in the list. So it starts off at 0, then it goes to 1, and then if we see that the start is greater than the end time, then we're going to be adding it to the list and appending it. But since it's not, we're just going to be keeping this, check if this is greater than this. It is, so we add this thing too. So that our final list for in this example would just end up with a list of this tuple and this tuple. So those two tuples. And at the end, we'll be returning the length of the selected list. So yeah, that's essentially how this works using a greedy algorithm approach. We can start to test our code. Let's say this is activities. Let's make this activities. I spelled that right. Next, we're gonna say, basically, we're going to print out activity selection of activities. So now if we did everything right, we should be getting the first value and then the second value. So we should get 2, because the maximum a single person can attend this one that goes from 1 to 4, and then this one goes to 8 to 9. So a single person can do these two activities, but he'd have to miss this activity because it's overlapping. If we change this number to 5, then it's all set because he can attend all of these, assuming he has the stamina to attend each and every activity. He can go all day. So, shoot, sorry. Did I make sure to? Yeah, I think I messed up, but 3. So, you see, 3 is the answer because the person can attend all 3 activities. We can we can check it with a longer list too, since we have some time. If the longer list goes like this, so he can go from 1 to 4, but then 3 to 5 he's going to miss this one, so we don't include that. We can't include this one either because he'd have to miss this one too. So yeah, basically, even I have trouble figuring out the whole thing, but if we run the code, it'll work on a large data set too, unlike a brute force approach where we'd loop through this list multiple times. We didn't exactly go through the brute force method into this, but assume so we know that this time complexity, because we're using a sorting algorithm and essentially looping through the list a single time, it's going to be a total of n log n. However, to an inefficient method would be looping through this list and then looping through every single list multiple times without sorting prior to the list, and then we would have to have a time complexity of n squared in that case. So yeah, hopefully you guys, and the space complexity is constant because we don't really need any additional space. There's this space that for the list, but that's a constant constant space operation, so there's going to be same. Yeah, so hopefully you guys understand the greedy algorithm approach, and yeah, I'll see you guys soon. See ya.